Hi, I'm Herb Gross, and welcome once again to Gateways to Mathematics, where our discussion today will center on the solutions for self-test 8 Form B. And this is the last self-test that we're going to be working on before you're going to be turned loose on your calculators. So basically what I want to do this time is, as we go through the problems, which by the way emphasize division using decimals, I want to also point out to you from time to time what the calculator will be able to do for you and what the calculator won't be able to do for you. And again, the usual admonition, please make sure that you have tried Form B on your own before you watch the tapes. So let's get on with this. Some of the problems are just tedious. It's a dirty job, but somebody got to do it. Let's go on over to the board, and we'll start with the solutions for self-test 8 Form B. The first problem is again going to deal with, after all, the title of the module is division of decimals, and so obviously our first problem will be involved with that. And again, we figured we would give two problems that would emphasize the need for grouping symbols. You see, in both parts A and B, without the parentheses, it would read 0.072 divided by 0.06 divided by 0.003. But the difference is, in part A, you're first going to divide 0.072 by 0.06, then divide by 0.003, whereas in part B, you're first going to divide 0.06 by 0.003, and then divide 0.072 by that quotient. So basically, what we're going to do is, remember, everything inside the parentheses is done first. So in doing part A, we're first going to divide 0.072 by 0.06, then divide that by 0.003. So getting on with that, we have 0.072 divided by 0.06, and you'll recall that we mentioned in the text that the most pleasant thing is when the second number is a whole number. To convert 0.06 into a whole number, we have to multiply, we have to move the decimal point 2 places to the right. That's the same as multiplying by 2 factors of 10. If I move the decimal point 2 places to the right here, I also have to move it 2 places to the right here. So this problem is equivalent to 7.2 divided by 6. But in this form, I just divide the 6 into the 7.2, lining up the decimal points. You see, once the decimal point is lined up, I just do this problem the same as if it was 6 goes into 72. See, 72 divided by 6. And by the way, to show you why that's the case, you see, how do you read 7.2 if you wanted to read it as a whole number? Without the decimal point, this would be 72, but the 2 is in the tenths place. So another way of reading this would be what? 72 tenths. And you see, if I do that, the problem becomes 72 tenths divided by 6. 6 goes into 72 12 times. The noun is tenths. So 12 tenths, little grammar here, 12 tenths. What does tenths mean? It means you divide by 10. And since when there's no decimal point, it's assumed to be after the digit furthest to the right, we take the decimal point, which is after the 2, move it one place. Did I say right? I meant one place to the left to divide by 10, and that gives us 1.2 for the answer, the same as we got the other way. And now what were we supposed to do next? Remember, after that division, we were supposed to take that answer and divide that by 0.003. And again, we use the same strategy. In order for this to have been a whole number, the decimal point would have to be over here. To put the decimal over there means that I've moved the decimal point 3 places to the right. If I move the decimal point 3 places to the right, I then have to move it 3 places to the right here also. But since the decimal point is between the 1 and the 2, as soon as I move it 1 place to the right, there are no more digits, so I have to annex 2 zeros. That reduces this problem to 1200 divided by 3, which you'll all recognize as 400 for the answer. And by the way, that's kind of an important thing for you to understand. Again, this quotient does not look the same as this, but the point is that 1200 is as many times bigger than 3 as 1.2 is bigger than 0.003. Whereas these numbers look different, they name the same ratio. Now remember, for doing part B, we first wanted to divide 0.06 by 0.003. And to do that, the same strategy as before. To make this a whole number, I have to move the decimal point 3 places to the right. If I move the decimal point 3 places to the right, I'm multiplying by 1,000. If I multiply one number in the ratio by 1,000, I have to multiply the other number in the ratio by 1,000. That means I have to move the decimal point 3 places to the right here. Since there are only 2 digits, moving it 3 places means I have to annex a 0, so this problem becomes the same as 60 divided by 3. See that? 1, 2, 3. 60 divided by 3, and that, of course, is 20. Now, remember what the problem was. See, by now you might have forgotten the problem. The problem is 0.072 divided by 0.06 divided by 0.003. And what we just saw was that this part over here, that part is what was 20. So the problem now reduces to taking 0.072 and dividing by 20, and we don't have to clean this up any because this is already a whole number. We simply take the 20, line up the decimal points, divide 20 into 0.072. Let's see how this goes. 20 doesn't go into 0, it doesn't go into 7, it goes into 72 3 times. 3 times 20 is 60, the remainder is 12. And what's the trick here? Since 20 has only 2's and 5's as prime factors, I know if I go on here long enough, the decimal will come to an end, so I give it another shot. I annex a 0, I bring down the 0, 20 goes into 120 6 times, now there's no remainder, now I've been amply rewarded, the problem is finished. It's 0.0036, that's the answer to the problem. And again, for those of you who still like to think of fractions in the traditional common fraction format, if you wanted to, you could have taken 0.06 divided by 0.003, change this into what? 6 hundredths divided by 3, 1, 2, 3, 3 zeros, 3 thousandths. This is now a common fraction problem. How do we divide using common fractions? Leave the first number alone, change the division to a times. Do you like the way I crossed those out? Reminds me of a cartoon I saw in The Wizard of Id, where somebody is doing a research problem, and he's saying, in over 30 years of studying snowflakes, no 2 snowflakes have ever looked identically, and just as he's about to say that, 2 identical snowflakes fall, and he steps on one of them and writes alike. So I just cross these things out and pretend they never happened, but watch what happens now. 1, 2, the 2 zeros here cancel with 2 zeros here, and the answer is the same 20 that we got the other way. All right? Now, basically, we'll keep on doing problems this way. I just want you to get used to taking quotients and to recognize that as soon as a divisor, if it's a whole number, as soon as that divisor has a prime factor other than a 2 and or a 5, you're going to get a decimal that will not come to an end in general. So we have to be prepared for that, and that means that in dealing with decimals, when we do division, we are quite frequently going to have to round off. And to get you ready for that, problem number 2 just says, round it off to the nearest tenth. How much is 26.76 divided by 6.3? And again, our strategy, for better or for worse, and what do I mean by for better or for worse? Without worrying about whether it's a nice whole number in terms of prime factors or not, the strategy is what? Always make sure that the divisor is a whole number. To turn this into a whole number, we move the decimal point 1 place to the right. If we move it 1 place to the right here, which means we multiplied by 10, I also have to move it 1 place to the right over here. And we then write this as what? 267.6 divided by 63. And now we do what? We divide the 63 into 267.6. We line up the decimal point. We say 63 goes into 267 4 times. 4 times 63 is 252. We subtract, we get 156. Bring down the 6. 63 goes into 156 twice. Twice 63 is 126. We subtract, the answer is 30. Technically speaking, we can now stop because we want this answer rounded off to the nearest tenth. So far we have this. Notice that 30 is less than half of 63. So therefore, the remainder here is going to be less than half, so the answer would be 4.2. But if we wanted to and didn't want to guess that way, just bring down another 0, and then you see what? 63 goes into 300 4 times. See, 4 times, and that would be again 252. And now you see, in rounding off to the nearest tenth, we look at the 100th digit, and since that's less than 5, we just drop it. By the way, while we're over here, I would like to point out one more thing to you. In a lot of places, they teach you a mechanical recipe that you may yourself still want to use, but you may not know why it works. When I went to school, I was never taught to move the decimal point over here. I was taught to just write the problem exactly as it occurred. See, when I went to school, we wrote the problem like this. Then we were told, move the decimal point one place here and also one place here. Well, I don't know if you noticed it. That's exactly what we were doing up here from a more logical point of view. When they wrote it in this form and said move the decimal point one place in both places, they were still saying what? Multiply both numbers in the ratio by 10. See, in many cases, I'm not going to show you new ways to do problems. I'm going to show you meaningful ways of understanding the ways you already know. At any rate, let's continue on, and let's apply this now to a money problem where people become more interested in this. To the nearest cent, how much is 0.09% of $2,540? And again, nothing has changed here except the fact that we can do this as a decimal problem now. See, percent still means divided by 100. And you see how we use the same definitions, just like a language. We learn what a term means, and we use it that way all the time. See, percent means what? Per 100, divided by 100. So we have 0.09 divided by 100. Of means times 2,540. The only difference is that in this module, we learned that to divide by 100, you move the decimal point 2 places to the left. Since the decimal point is already over here, to move it 2 places to the left, I need 2 more placeholders. So instead of having 0.09, I need 2 more zeros between the decimal point and the 0. That gives me 0.0009 times $2,540. I now take the $2,540 and multiply that by 0.0009. And how do I do that? I multiply as if there were no decimal point here. That gives me 22,860. I count the number of decimal digits to the right of the decimal point, 1, 2, 3, 4. I then count in 1, 2, 3, 4 places. So the answer is $2.2860. You know, this is interesting. Many, many years ago, there was a coin called a mill, just like in the word millimeter. It was a coin that was a tenth of a penny. So in the old days, instead of saying, just like we say $2.28, in the old days they had a coin called the mill, and they would say this is $2.286 mils. See, but we only measure to the nearest penny. I mean, the story is you can't even buy anything for a penny today, let alone for a tenth of a penny. You may wonder why we still use mills in business today, and the answer is a tenth of a penny may not be very much, but on several billion items, it's a lot. So when you're dealing with high finance, you have to be very, very careful about fractions of a cent. Because whereas the rate is small, if the total number is large, you see that can be quite a significant change. At any rate, we now round this off to the nearest cent. So since this is the cents column and this figure is a 6, we round off the 28 cents to 29 cents, and that gives us the answer. And again, keep in mind the fact that once you know several ways of doing a problem, you can use whichever way you prefer. For example, some people say, I thought that dividing by 100 meant over 100. Could you do that if you wanted to? Sure, you could write this as 0.09 over 100. Technically speaking, this is not a common fraction because to be a common fraction, you have to have 2 whole numbers. How could I make this a whole number? By moving the decimal point 2 places to the right. But if I move the decimal point 2 places to the right here, that means I multiplied by 100. I also have to multiply by 100 down here. That means tacking on 2 zeros. Notice that this becomes 9 over 10,000, which is 9 parts per 10,000. What's this number? 9 what? Tenths, hundredths, thousands, 10,000s. Now, if all of this gives you a migraine headache, at least have a ballpark figure. Say to yourself, look, 1% of 2,540. See, how do you find 1%? It's 1/100th. See, and multiplying by 1/100th is the same as dividing by 100. How do you divide by 100? You move the decimal point 2 places to the left. So 1% of $2,540 would be $25.40. Therefore, 1/10 of 1%, see, move the decimal point one more place, would be $2.54. And then simply notice that 0.09% is slightly less than 1%. See, catch that? 0.09 is less than 0.1. And so the answer should be what? A little bit less than $2.54. So even if you made a careless mistake up here, what difference does it make? You still know you're in the right ballpark. You're a little bit less than $2.54. Problem number 4 is again designed to remind you that whether you're dealing with decimals or anything else, you have to keep track of when you're dividing and when you're multiplying. Problem number 4 says, part A, how much is 40% of 80? Part B says 40% of what number is 80? If you're memorizing, notice how close these two problems seem. And yet they're completely different. In fact, one way of seeing this, I have a note on this later, but we'll talk about it then. Let's mention it now. If you take 40% of a number, that's less than the whole thing, right? The whole thing is 100%. So if you're taking 40% of a number, you're taking less than the whole thing. So this answer has to be less than 32. If 40% of the number is 80, the whole number itself must be, in other words, if 40% of a number is 80, the entire number must be more than 80. So the answer to A has to be less than 80, and the answer to B has to be more than 80. And these are the kind of things that you should be able to figure out if you're not panicked by the symbolism. At any rate, let's see how we proceed now. Let's do it by decimals. Percent means divide by 100, and the way you divide by 100 is you move the decimal point 2 places to the left. So to remove the percent sign, I move the decimal point 2 places to form 0.40. Of means times, so part A becomes 0.40 times 80. 40 times 80 is 3,200. There are 2 decimal digits to the right of the decimal point, so I have to move it in 2 places. The answer is 32. By the way, you could have done this as a fraction problem. You could have said, look, 40% is 40 over 100. That reduces to 4/10, which is 2/5. 2/5 of 80, 80 divided by 5 is 16. 16 times 2 is 32. Same answer. Part B is a switch. See, in part B, the 80 now goes to the right-hand side of the equal sign. This is still 2/5. Of still makes the translation into times, but the 80 is now over here. See how the blank has switched around? This looks like a multiplication problem, but it's a division problem. 2/5 times blank equals 80 is the same as saying blank equals 80 divided by 2/5. And to divide by 2/5, you multiply by 5/2. 2 goes into 80 40 times. 40 times 5 is 200. And you can do these problems other ways. I don't want you to think you have to do the problem this way. I don't know every possible way of doing these problems. Let me just show you a couple of more. See, 1% of 80, the easiest way to find a percentage is find 1%. Because to find 1% of a number, you just move the decimal point 2 places to the left. So 1% of 80 is 0.8. See, technically 0.80, but you don't need that in there. It's only a placeholder. So if 1% is 0.8, 40% is going to be 0.8 40 times. And 0.8 40 times, see, 8 times 40 is 320. There's 1 digit to the right of the decimal point. You move that in here, the answer is 32. Same thing with part B. If 40% is 80, see, if 40 times something is 80, each one must be 80 divided by 40, right? If you can buy 40 for 80 cents, each one must have been 2 cents. See, if 40% is 80, 1% is going to be 80 divided by 40, which is 2. 100% is 1% 100 times. If 1% is 2, 100% is going to be 2 times 100, which is 200. So there's lots of ways of doing these things. And what are the rough hints again? Let me show you some more things. 40% is less than 50%. And 50% is half. So whatever 40% of 80% is, whatever 40% of 80 is, it's less than 50% of 80, which is half of 80, which is 40. So before you even start part A, the thing you should know is what? That the right answer is less than 40. As far as part B is concerned, or A and B together are concerned, when you take 40% of 80, the answer has to be less than 80. If 40% of a number equals 80, that number has to be more than 80. So those are little guidelines that you can use to see if your answers are at least reasonable. Okay? Now let's get into this problem of what do we do when we do get these decimals that never come to an end, where the same cycle of digits repeats endlessly. We talked about that during the lecture. Let's review it during the exercise set. 5a says write 0.567 bar as a common fraction in lowest terms. The first thing you have to remember here is that the bar over the numbers tells you that that's the cycle that repeats endlessly. In other words, if I call this number n for number, and put the 0.567, and by the way, I have to make these bars careful, because if I don't do this right, you might say, I wonder if that bar is over the 5 or not. It makes a difference whether the 5 is part of the cycle or not, you see. Now, what does that mean? It means that the cycle 0.567567 is going to repeat endlessly. And the way we handle that is we notice that the next place we can put the decimal point to make the same cycle repeat endlessly is, since it's a 3-digit cycle, we move it 3 places to the right. And when you move the decimal point 3 places to the right, you're multiplying by 1,000. So 1,000n is what? It's 567.567 endlessly. And here's the trick. You see the decimal part here is 0.567 endlessly. The decimal point here, the decimal part here, is 0.567 endlessly. So when I subtract, you see the endless part is going to drop out. See, I get all zeros, which is the same as nothing there. So I get what? 567 over here. 1 n from 1,000 n's leaves me with 999 n's. If 999 times n is 567, n itself must be 567 over 999. In fact, the easiest way to do this is by a technique that we will often use later in algebra courses. You see, the 999 is multiplying the n. To get rid of multiplying by 999, we divide by 999. See, that cancels. But if you divide by 999 on one side of the equal sign, to keep the seesaw balanced, you have to divide by 999 on the other side. But no matter how you do this, this comes out to be 567 over 999. Notice that the sum of the digits here, 5 and 6 are 11 and 7 are 18. 18 is divisible by 9. That tells me that 9 is a factor of the numerator. The numerator is 9 times 63. The denominator is 9 times 111. I cancel the 9s. I now have 63 over 111. 1 plus 1 plus 1 is 3. So my denominator is divisible by 3. 6 plus 3 is 9. So my numerator is divisible by 3. The numerator is 3 times 21. The denominator is 3 times 37. So the fraction is 21 times 37. And this can't be broken down any further because 37 is a prime. So the answer to the problem is 21/37. And how do you find out if that's right? Just take 21 over 37 and rewrite it as a decimal. And we get what? 37 goes into 210 5 times. 5 times 37 is 185. We subtract, we get 250. We bring down the 0. 37 goes into 250 6 times. 37 times 6 is 222. We subtract, we get 280. 37 goes into 280 7 times. 7 times 37 is 259. We subtract, we get 21. And now look what's happened. We started with 21, followed by nothing but zeros. We reach down here. What's happening? A 21 followed by nothing but zeros. So the same cycle will just keep on going forever. 567, 567, 567. And if we don't like to use this thing endlessly, what can we do? We can round it off to whatever degree of accuracy we want. Part B says round off this number to the nearest millionth. Well, what is 0.567 endlessly? It's 0.567, 567, 567. Where is the millionth place? Tenths, hundredths, thousandths. See, in fact, you can even count by whole numbers. See, tens, just don't start with ones here. Tens, hundreds, thousands, 10,000s, 100,000s, millions. And now instead of saying millions, you say millionths. See, this is the millionths place. What's the digit immediately to the right of the millionths place? It's a 5, actually more than 5 because this is a 6 over here too. In other words, this is more than halfway because this is 56. That means I do what? Change the 7 to an 8 and drop the rest of the digits. So the answer to part B is 0.567568. And this, you see, is an easy common fraction. It's 567,568 millionths. See, as long as the decimal terminates, no matter how many digits, we can convert it to a common fraction very easily. Okay, Now, part C tries to warn us about the same thing I warned you about in the lecture and just a few minutes ago over here. See, now I say write 0.567, but now the bar is only over the 7 as a common fraction in lowest terms. You see, if I call this number m, the only part of the decimal that's repeating is the 7. See, it starts with 0.56, and the 7s go on endlessly. So notice that the first place I can put the decimal point to capitalize on the repeating part, I have to get the 5 and the 6 out of here. So the first point that I can put the decimal point is where? Between the 6 and the 7. That's 7, 7, 7, 7. But moving the decimal point 2 places is the same as multiplying by 100. The next place I can put the decimal point is between the first 7 and the second 7. That's multiplying by 1,000. In other words, 1,000m is 567.7 bar. 100m is 56.7 bar. The important point now is that when I subtract, the decimal parts cancel. See, 7 bar minus 7 bar is 0. What am I left with? 56 from 567 is 511. 1,000 m's take away 100 m's is 900 m's. If 900 times m is 511, m itself must be 511 divided by 900. That's 511 over 900. And by the way, without working too hard, I know that that's a prime number. I mean, not prime, it's in reduced form. How do I know that? Because 900 is 9 times 100. The only prime factor that 9 has is 3. The only prime factors that 100 has is 2 and 5. So the only prime factors of the denominator are 2, 3, and 5. But the numerator doesn't have 2, 3, or 5 as a factor. It can't be divisible by 2 because it ends in 1. It can't be divisible by 3 because the sum of the digits is 7, which is not divisible by 3. And it can't be divisible by 5 because it doesn't end in a 0 or 5. So the answer to part C is 511 over 900. And the way we check that is we simply divide 900 into 511. And how do we do that? Put down your zeros over here. 900 goes into 5110 5 times. We subtract 4,500. We get 610. We bring down the 0. 900 goes into 6,100 6 times. That gives us 5,400. We subtract, get 700. Bring down the 0. 900 goes into 7,000 9 times. 900 times 7 is 6,300. We subtract, we get 700. Now notice the cute thing that happened. We get a repeating remainder, but it doesn't start from the beginning. You see, here we had what? The remainder was 700. What's the remainder here? 700. So this thing here is just going to repeat over and over and over again. And by the way, if you want to compare the difference between A and C, see, in A, the number is 0.567567,567. In C, the answer is 0.567777. See, notice that they agree up to here. The first place that they're different, C has the greater digit, so the answer to C represents a bigger number than the answer to A. And that takes care of the computational drill problems. Now we want to apply this to word problems. And that's where it's all at. That even if you have a calculator, if you don't understand the wording, you're not going to be able to solve the problem. Basically, in problem number 6, we're told that a gallon of paint covers 427 square feet. And we're then asked that to the nearest tenth of a gallon, how much paint will we need to cover 2,380 square feet? I threw this wording in on purpose to show you that if you understand what you're doing, you don't even have to know what the label means. We haven't studied area yet in this course. You might not even know what square feet means. But you don't have to. What you do know is what? Whatever square feet are, 1 gallon covers 427 of them. So 2 gallons would cover 854 of them. See? In other words, every gallon covers another 427. The problem says, how many gallons would it take to cover 2,380 of them? See, in terms of the language of Module 3, what we're asking is 2,380 a multiple of 427? And if not, in between what 2 multiples is it? And how do you solve that kind of a problem? Since you're counting by 427s, you want to see how many times 427 goes into 2,380. So we take 427 and divide by 2,380. And basically, you see, what happens over here is we say 427 goes into 2380 5 times. 5 times 427 is 2,135. We subtract, we get 245. So if this was a Chapter 3 problem, we would say that you would need what? 5 full gallons and 245 of the 427 parts to make up another gallon. But this isn't Chapter 3, this is Chapter 8. And in Chapter 8, we're supposed to know decimals, so we annex a couple of zeros here, and we just carry on the problem. We bring down the 0, we say 427 goes into 2450 5 times again, that's 2135. Now we subtract, we get 315. We bring down the next 0. 427 goes into 3,150 7 times. That gives us 2,989. And at this point, we can stop because the problem says what? To the nearest tenth of a gallon. This is the 1/10th place. And since this is a 7, to the nearest tenth, it's going to be 5.6 gallons. And again, if this bothers you, go back to whole numbers. 5.6 is between 5 and 6. If you can cover 427 square feet with 1 gallon, with 5 gallons you're going to cover 427 5 times. That's 2,135. With 6 gallons, you're going to cover 427 square feet 6 times. That's going to be 2,562. How many square feet do you want to cover? 2,380. So it's like Goldilocks and the Three Bears again. We tried 5 gallons, but that wasn't enough. And we tried 6 gallons, but that was too much. And we tried 5.6, and to the nearest tenth, that was just right. So that's the fairy tale of Goldilocks and the paint. All right? But you see how this idea works? You can do all of these problems when you're stuck, just by thinking arithmetically. Don't let the big terms scare you. Do the opposite of what you're taught to do in an English writing course. Don't find the biggest word that says what you want. Find the smallest word that says what you want. See? Find the easiest way to understand it. Like take problem number 7, for example. It says a salesperson earns as a commission 17% of the sales. If her commission is $391, how much were her sales? See, people say 17%. I don't know how to handle that. Don't worry about it. 17% means that out of every $100, you get $17. See? So in other words, on $1, she would make 17 cents. On $100, she makes $17. On 1,000, now watch how this works. See? 1,000 is 110 times. So if you make $17 on a $100 sale, if that's your commission, you're going to make 10 times that amount on a $1,000 sale. You see, if I multiply the sale by 10, I multiply the commission by 10. That's what's nice about a percentage. If you double the sales, you double your commission. See, 10% of 100 is 10. 10% of 200 is 20. It's the same percent, but if you double the amount, you're doubling the amount that you get with the 10%. At any rate, with $1,000, she'd have earned $170. With $2,000, her commission would have been $340. By the way, in this problem, what was her commission? It was $391. And therefore, even if you don't know how to handle anything beyond this, do you now know that since she would have had to have sold $2,000 worth to make $340, to make $391, she must have sold more than $2,000 worth. Let's find out what the exact amount is. We're told that 17% of her sales equals her commission. What are we told here? What's the $391? This is where reading comprehension comes in. I can't emphasize that enough. The $391 isn't the sales, it's her commission. So in the formula that says 17% of the sales equals the commission gets replaced by $391. 17% as a decimal is 0.17. See, percent still means divided by 100. That means we move the decimal point 2 places to the left. So it's 0.17 times blank equals 391, where blank is the amount of the sales. This looks like a multiplication problem, but because one of the factors is the unknown, it's really a division problem, and blank is equal to what? 391 divided by 0.17. And how do we handle that? Make this a whole number again. You see, basically, once you're down to here, we're back to problem number 1 or 2. See, the hard part was to get to here from the word problem. Once we're here, we just do these problems the same way. We move the decimal point 2 places here. That means we have to move it 2 places here. That means we have to annex 2 zeros. So it's 17 goes into 39,100. 17 goes into 39 twice. 34 from 39 is 5. We bring down the 1. 17 goes into 51 3 times with no remainder. And again, be careful. Every time there's a digit in the divisor, the dividend, there has to be a digit in the quotient. So therefore, as you bring down these zeros, you have to put zeros over here. And that means that she must have sold $2,300 worth of material. How could we check this? If we took $2,300 and took 17% of that, that should come out to be $391. But notice our estimate. Before we started this problem, we said what? The answer to this problem has to be somewhat more than 2,000. It was somewhat more than 2,000, so we know we're at least in the right ballpark. Okay, problem number 8. It says 19 people equally share the cost of a $160 gift. Rounded up to the nearest dime, how much does each pay? I haven't worded the problem this way yet about rounded up to the nearest dime, but it's a very simple concept. How much each person pays is called dollars per person. Dollars per person still means dollars divided by people. See? Dollars per person. How many dollars were there? 160. How many people were there? 19. So how do we get the answer? We take $160 and divide that by 19 people. How many times does 19 go into 160? Let's do it as a money problem. 19 goes into 168 times. 19 times 8 is 152. We subtract, we get an 8. Bring down the 0. 19 goes into 84 times. 4 times 19 is 76. We subtract, we get a 4. Bring down the 0. 19 goes into 40 twice. Get 38. Subtract. And so far the answer is what? $8.42 plus. In other words, for this to come out right, everybody has to give a little bit more than $8.42. But the instructions of this problem didn't say round off to the nearest dollar. It didn't say round off to the nearest dime. It said round up to the next dime. And the first 10-cent multiple that you get that's more than 42 cents is what? 50 cents. In other words, rounded up to the nearest dime, this is $8.50. And the reason that you round up when you're sharing a cost is you'd rather wind up with too much money than too little money. You see, all it would have taken was $8.42. All it would have taken is $8.42. But by taking $8.50, you're collecting a little bit extra. Look, if each person paid $8.50, multiply that by the 19 people, we get $161.50. All we needed to collect was what? $160. Therefore, we have an overage of $1.50. Now, not only can we give a nice gift, but for the same price, we can throw in a card. That's the way people basically do things. If you want to make sure you're going to be a little bit over, figure out what the exact cost will be, tack a little bit onto that, then if there's any mix-up, you're still okay. So lots of times in the real world, we round up rather than rounding off or rounding down. Okay, now we're going to finish up with a couple of problems here that I think will show you, again, reading comprehension and how you shouldn't be afraid of big, messy numbers. It says at most 32% of your monthly take-home pay can be spent for rent. By the way, from here on in, since most of the problems are going to be word problems, and it takes a long time to write the word problems, I will probably paraphrase some of the problems just to save more space on the board. But basically, at most 32% of your monthly take-home pay can be spent for rent. And the question says, if your monthly take-home pay is $1,520.47, to the nearest dollar, how much can you afford to pay for rent? See, these numbers look a little bit messy. That's where the calculator is going to help you. But even with the calculator, if you don't know what to do, you're stuck. So what should we do? Let's go back to the baby way of doing this problem. Let's see what this problem really says. What it really says is that for every dollar you take home, at most 32 cents can be paid for rent. So I'm going to use an abbreviation here so it will sound more advanced. MTHP, monthly take-home pay. Doesn't sound impressive that way? Okay, if your monthly take-home pay was $1, you can afford to pay 32 cents a month for rent. Well, that's ridiculous. I mean, this is just the ratio. You see, if your monthly take-home pay was $100, you can afford to pay $32 for rent. If it was $1,000, you could afford to pay 10 times that amount. See, at $1,000, you could afford to pay up to $320. At $2,000, you could pay double the $320. That would be $640. And if you want to even fill in more, see, what's the average? What's halfway between $320 and $640? See, the difference between $320 and $640 is $320. Half of $320 is $160. That will give me, what over here? $480. A quick way of finding the average of two numbers is to add the two numbers up. $320 and $640 is $960, then divide by 2. So in other words, what this says is, if your monthly take-home pay was $1,000, you could afford to pay $320 a month for rent. If it was $1,500, you could afford to pay $480. If it was $2,000, you can afford to pay $640. By the way, what was your monthly take-home pay in this problem? $1,520. Isn't that just slightly more than this? Therefore, what should we expect the answer to be? Before we even start fooling around with this, we know that the most we can afford to pay is a little bit more than $480. By the way, does that mean that's all we're going to do? Have you known people, maybe yourself included, who can only afford to spend $487? You find something you like for $750, and you say, close enough. See, knowing math is not going to stop you from getting bankrupt. The advantage of knowing math is that when you go bankrupt, you'll know why. The poor guy who doesn't know math, he goes bankrupt and doesn't even know why. But by learning this course, you will be just as broke as ever, but you'll know why. Knowing the math may not even change your spending habits, but at least you'll see what's happening over here. Anyway, let's see if we can figure out what's happening from this chart. What this chart says is, every dollar that you make, 32 cents of it can go into rent. In other words, what are you saying over here? 32% of your monthly take-home pay. 32 cents times the number of dollars that you make is the maximum amount you can pay for rent. See, 32% is 0.32. Then the amount you're given here is $1,520.47. And now how do you find the maximum rent? Just multiply these two numbers. And that's the hard part. See, that's where the calculator will help you. The calculator will do this problem for you in seconds. In seconds. But is this such a terribly hard problem, by the way? I could do it. Of course, you'll notice I do it before you get here. See, when nobody else is here, I come into the studio and pre-write the boards. And after they train me a little bit, all the mistakes are taken out. And even then, have you noticed how many I've made? It's not easy. Anyway, we multiply this whole thing out. And what do we do now? There are 4 digits to the right of the decimal point. We move the decimal point in 4 places to the left. We get $486.55.04. But the problem says to the nearest dollar, since 55 cents is more than half of a dollar, we round the answer up to $487. Okay? And now, the last problem is exactly the same as the one we just did, except they've switched something on us. Instead of telling us the take-home pay and asking us how much rent we can afford to pay, they tell us what rent we're paying, and now we have to figure out how much we're earning. See, it says under the same conditions as in 9. What does the same conditions mean? You can only afford to pay 32% of your monthly take-home pay for rent. It says, what must your minimum monthly take-home pay be if your rent is $525? This comes up, you see, this comes up in the real world if you go apartment hunting and you see the apartment. And now you don't look at your monthly rent, you see the price of the apartment. They say it's $525. Now you decide you like it. You remember that you can only afford to pay 32% of your take-home pay for that. So now you ask the question, am I making enough to pay for this? In other words, how much should my monthly take-home pay be if I'm going to live by that budget? See, the formula is the same. 32% of your monthly take-home pay is going to be the rent. What's changed over here is that it's the rent that's given as $525, not the monthly take-home pay. So the monthly take-home pay is still unknown. You're still multiplying by 0.32. The rent is $525. So if blank times 0.32 is $525, blank itself must be $525 divided by 0.32. How do we do this problem? To make this into a whole number, move the decimal point 2 places to the right. If you move it 2 places to the right here, you also have to move it 2 places to the right here. So we're now going to take what? 52,500 and divide that by 32. 32 goes into 52,500. Well, we got a couple of minutes. Let's do it. 32 goes into 52 once. 32, subtract that from 52 is 20. Bring down the 5. 32 goes into 205 6 times. 6 times 32 is 192. Subtract 192 from 205, that's 13. Bring down the 0. 32 goes into 130 4 times. 4 times 32 is 128. Subtract gives you a 2. Bring down the 0. So the answer is 1640. And by the way, you don't have to go on this way as a decimal. The remainder is what? 20? 30 seconds. Is that more than half a dollar or less than half a dollar? 16 out of 32 would be half of a dollar. So 20 out of 32 is more than half a dollar, so we round up the 1640 to 1641. And all that means is that if you want to stay within your budget and you like this $525 a month apartment, you simply check your take-home pay. If your take-home pay is $1,641 or more, you can afford that apartment within your budget. If your take-home pay is less than that, you're going to extend your budget, which means if you do this thing emotionally, you can get in over your head. If you still like the apartment, are there ways perhaps of adjusting your income? See, sometimes in life you have to give a little to get a little. It doesn't say that you can't live in the apartment. It means that if your figures are correct, you're going to have to give up on something else to maintain that luxury. In any event, this finishes up the first phase of our course. Starting with our next module, you'll be allowed to use the calculator, and I will show you many computational devices to help you keep track of when do you divide, when do you multiply, etc. But I'd like you to now make sure that before you go on to Module 9, in your study guide, there is an extensive review of the first 8 modules. I want you to do all of those exercises because my philosophy is I want to make sure that you can do the computational necessities without the aid of a calculator before I turn you loose with the calculator. Because basically, I want to make sure you understand what you're doing before I give you tools that will mechanically allow you to get answers. Not because I'm nasty, but because I may be nasty, but that's not the reason. The reason I want to do this is in the event that you get a ridiculous answer by punching the wrong key on the calculator, I want your common sense, your number sense, so to speak, to warn you that something is going on wrong here. At any rate, until next time, keep learning, have fun, stay young.